So welcome to our volume and surface area review. We're going to go through some basics here of volume and surface area to make sure that as we start our chapter in geometry about volume, that we all are on the same page for the basics. So let's still first talk about what are dimensions. So dimensions are things like length, width, height, depth, even base can be a dimension. And these words are sometimes used interchangeably in formulas and in different books, so it gets a little confusing. So a one-dimensional object, or what is 1D, is just one of these things. If you're just dealing with the length of something, or you're just dealing with the height or something, or you're just dealing with the depth of something, that's one-dimensional. Things like lines are technically one-dimensional. If you remember in geometry, we talked the very beginning of the year about lines being what are called undefined. Points, lines, planes, being things that are called undefined. Because when I draw a line, I want to simulate one dimension. Obviously, if I put enough of these lines on top of each other, I would start to have two-dimensional figures. But this line is supposed to represent something that has only length, but no width or depth, okay? So lines are one dimension. Flat objects, things like planes, shapes, basic shapes like a circle, a square, a rectangle, parallelogram, those are all considered two-dimensional objects. They are things that have two dimensions. We might call a rectangle, we might call this length and this width, or we might call this height and this length, or we might call this depth and this length. And then when we have a triangle, we might call this the base and this the height, or we might even call this the base and this the altitude. But we're still talking about two dimensions, and that makes it a two-dimensional shape. A three-dimensional shape is what we'll be calling in this chapter our solids. They're things that take up three dimensions. We can represent them on a piece of paper, but we can't really show them on a piece of paper. So things like a rectangular prism or a pyramid or a trapezoidal prism or a cylinder, all things that we can draw a picture of. This is supposed to represent a cylinder, but in order to see it in real life, it takes up three dimensions. And we might call those dimensions height and depth and base, or we might call them width and height and depth, or we might call them length and base and depth, but still there's three different descriptive words. The other thing that we need to talk about, what is volume, what is area versus volume versus surface area. So area only deals with a two-dimensional object, and we multiply the two dimensions to get the area. So we might multiply, if I call this the length and this the width, we might multiply these two together on a rectangle to get the area. On a triangle, we might multiply the base times, we learned it as the height, really it's the altitude. But that would give us a rectangular shape, so we have to divide it by 2 to take into account that it's a triangle. Volume is a three-dimensional object. So if we talk about the volume of the cylinder, how much space can we fill up inside of it? So the volume, if it's a can of soup, how much soup can we put in it? If, what can we put inside of it? The surface area, this is what gets a little confusing for kids, is a 2D representation. We're talking about two dimensions, but only a 3D object actually has a surface area. But it's still a 2D representation, but because we're talking about the areas on the surfaces. So for instance, if we take a cylinder, we have the top circle, the bottom circle, and if we were to cut open, say this is a can of soup, and cut it open, this actually becomes a rectangle. I know I look lovely this morning, but I was saying that this can of pumpkin is a cylinder. It has a volume. I'm going to hold this in front of my face. It has a volume. The amount of pumpkin inside fills up the can. It also has a surface area. Let's say for some reason, pretend this was a silo, which is a big, tall, huge cylinder that sits at a farm and holds grain. So if I want to find the surface area, the circle on top represents a two-dimensional object. The circle on the bottom represents a two-dimensional object. And while it might be difficult for you to visualize, the outside of the can is actually a rectangle. And I like using cans because you can see this so well. I actually rip. Can went flying, sorry. If I actually rip the label of the can off, you can see it's a rectangle. Let me pick up the can. I don't know where the can went, but another example of a three-dimensional shape is the rectangular prism of Kraft macaroni and cheese. It has a volume. It has an amount of macaroni and cheese product that fits inside of it, obviously uncooked. It also would have a surface area. That would be the area of each of the sides. So say I wanted to take a piece of wrapping paper and wrap up the macaroni and cheese. I would need to know if my piece of paper was going to be enough to completely cover it. In this case, it's not going to be. It's going to be short on that side. I'm going to do some follow-up questions to what I just talked about. You can pause the video, see if you can answer these, and then come back and listen to my explanation. You might say, Mrs. Falk, I know how to do all this. But basically, how do we calculate one dimension? I talked about that's either length or depth or width or height. One dimension, and how we calculate it, we measure it. Or if a measurement's given to us, we know what it is. The only time that we might have to calculate one dimension is when we are dealing with a perimeter. A perimeter is the outside of a shape. And that is not the shape I wanted. It's the outside of a shape. So in this blue rectangle, the red is the perimeter. And in that case, we would add all of the sides up. Same thing if I had a triangle. To get the perimeter, I would need to figure out the measurements of each side. In my geometry classes, to do that, I might have to draw an altitude, create right triangles, and use the Pythagorean theorem to do that. If I have a circle also has perimeter. In a circle's case, though, the perimeter of a circle is known as the circumference. And to find that, we are dealing with finding the radius. Twice the radius would be the diameter. And we multiply the diameter by pi. So to find the circumference, it's pi times the diameter. How do we calculate area? In order to calculate area, we're talking about two dimensions, and we need to find the measurement of those two dimensions. So for instance, in a rectangle, whatever we want to call this side, the length times the width, we could call it the base times the height. What we could call it the length times the depth. We multiply those. In a triangle, the height is the altitude of the triangle. we find the base, multiply it by the height or the altitude, and take 1/2 of that. If we have a triangle that looks more like this, our altitude might be, draw a line here, beyond the actual triangle. It's wherever the highest point would connect with the base. So in this case, we would still find the height. We'd multiply it by the base, which is just this part, and divide by 2. For a circle, so actually let me do this. For a circle, it's the radius squared, because the only dimension we actually have in a circle is a radius. What we're saying is we take 2 radiuses and multiply them by each other. And then we multiply that by pi, by 3.14. But we're still dealing with 2 dimensions in a circle. We just remember from geometry that all of the radii in a circle are congruent. So we can take any 2 of those. So really we only need to measure it once and times it by itself. So those are examples of how we calculate area. To calculate volume, there's a lot of formulas, but in any case, we are actually finding the area of the base and multiplying it by the height. Hey, it's me again. So we're talking about finding volume. So for instance, in this box of Kraft macaroni and cheese, if I wanted to find the volume, I find the area of one of the bases and multiply by the height. Now, a rectangular prism is called a rectangular prism because every side is a rectangle, including the bases. So if I find the area of a base, I can just find the area of one side. It could be what I would call the bottom. It could be what I could call the top. It could be what I call the front, the back, or one of the sides. And when I find the area of one of these bases, I multiply by the height. Meaning, if I use this as the base, then it's sitting, you can't see that, it's sitting on its base, and this becomes the height. With other shapes, the base is a little bit more predetermined. So for instance, back to my now unwrapped can of pumpkin. The base of a cylinder is always the circle. Even if I have it sitting upside down, it's still sitting on the circle. So I find the area of the circle and then multiply it by its height. If I'm using the container of Hershey's cocoa, natural unsweetened cocoa, the base of this would clearly be this bottom, although that is not a regular shape. And we're not going to deal with that in geometry, but there are ways to find the area of this. I would then multiply it by the height. The only time that this gets confusing is when I have a triangular prism, which I do not have here in front of me. But with a triangular prism, since there are triangles at both sides, you normally will see it drawn in a book with triangles at both sides. But since it's a triangular prism, the base is a triangle. You have to imagine that tipped on its side so that it now sits on the triangle. We'd find the area of the triangle, multiply by the height, that's the volume. Hexagonal prism, same thing. You'd have a hexagon, the bottom and the top. You'd find the area of one of the hexagons and multiply that by the height to get the volume. Calculate surface area. Well, first of all, we would want to spell it correctly. It's not spelled correctly. I'm sure there's other typos on this, but I can't fix that right now. How do we calculate surface area? So for that, we're going to use, again, a 3D object. We are going to find the area of every side, and we're going to add those together. And we talked about how our surface area and volume related. They both deal with three-dimensional objects. Volume, though, is a 3D representation of how much space is inside the shape. Surface area is if we found the measure of each of the outside surfaces and added those together. So it's actually a 2D, two-dimensional representation of the space outside the three-dimensional object. And now to confirm that you know the formula. So how do you find the perimeter or circumference of a shape, and why is that one-dimensional? So we talked about earlier, to find the perimeter, you add up all of the sides of the shape. To find the circumference, you're actually finding what I've drawn in red here, the outline of the circumference, and its circumference equals pi, which usually we use 3.14, times the diameter. You also may see the formula 2 pi r. Remember, you can multiply in any order, so 2 times the radius is the diameter. To find the area of the following, and why are they two-dimensional? A rectangle, a square, a triangle, a parallelogram, a trapezoid, and a circle all represent flat objects. So for a rectangle, depends what formula sheet you use, but basically you are multiplying, oh, I got two rectangles there by accident. You are multiplying the length times the height. Sometimes you'll see it as the base by the height. Sometimes you'll even see the width by the length, but these two dimensions you're multiplying. For a square, it's the same theory. You're multiplying the two sides together, but since they are both equal, you will sometimes see this formula written as s to the second power squared, because a square, the length and the height, or the width and the height, or the base and the depth, or whatever you want to call it, are always going to be the same s, which stands for length of side. In a triangle, the formula is 1/2 of the base times the height. In this case, lowercase b being the bottom of the triangle, and height being what we now call the altitude. I think it would be much less confusing if we just said 1/2 of the base times the altitude of the triangle. But basically, base times height would give you a rectangle. Divide a rectangle in half. That's bad drawing, but along its diagonal, you get two triangles. So that's where the theorem comes from. A parallelogram. See if we have a shape here for a parallelogram. We don't seem to. I'm going to make my own parallelogram. I don't know why it keeps drawing two, but I'm going to live with it. So move that side in. This is a little messed up, but you get the point here. That is a very bad parallelogram. Now I don't even have a parallelogram. I think you get that point here. There should be that point at the top. That's the problem. That looks a little bit better. But same thing, it is 1/2, not 1/2, sorry, it is the base times the height. That's the height, or that's the height, or that's the height. Trapezoid, we've dealt with a lot of trapezoids in this class of geometry, because we have had trapezoids, I had a whole lesson on trapezoids. So for trapezoids, try and highlight this, it is, whoa, okay, that looks a little bit more like a trapezoid. It is 1/2 of the sum of base 1 plus base 2 times the height. The reason it's half, base 1 plus base 2 is it's basically the average of the bases times the height. And the last one we have, that's not the shape I wanted though, is the circle. And for a circle, my circle over here, this formula is area equals pi. Whenever we're dealing with a circle, we usually deal with pi, radius squared. And it's radius squared because in a circle, really the only dimension we have is a radius. But all radii are congruent. So if I take two radii, which are congruent, multiply them together, it's the same as radius squared. Once again, it's two-dimensional, so I need two dimensions, times pi. And that's the formula. Review of volume and surface area and area, etc. We're going to go over finding the volume of a rectangular prism, a cylinder, a pyramid, a cone, and a sphere. How are they related? Well, I spoke earlier in this video about to find the volume of either a rectangular prism or a cylinder. I also talked about finding even a trapezoidal prism, a triangular prism, any of those things that have bases that are the shape. You would find the area of the base, running out of room here, times the height. You'll often see this in formulas as capital BH, and the capital B means the area of the base. When you get to things like pyramids and cones have in common that the base, for instance, of a pyramid might be a square pyramid, might be a rectangular pyramid, might be a triangular pyramid, but the top of it is not another triangle in a triangular pyramid, or not another rectangle in a rectangular pyramid, but a pointy top. And so the thing that I try to just always say, remember there, and if you look at formulas, you'll see this fraction of a third. If you find the area of the base of the pyramid or the cone, multiply it by the height, and then divide by 3 or take a third of it, then you will have that. Once again, you get formula sheets, but that's what it is. Remember, a cone is the same thing. The cone difference is it just has a circular base. Still, if you find the area of the circular base, multiply by the height, and divide by 3, you get the volume of a cone. And then the last one that's kind of unique would be a sphere, which is, I don't really know how to draw this, but it is a round ball. And for that one, the volume equals 4/3 pi r cubed. And since this is a unique formula, I try and remember here that since we're talking about volume, it's going to be a dimension to the third power, so radius cubed. And instead of the 1/3 of a pyramid and a cone, the volume of a sphere is 4/3. The only other thing I want to talk about would be surface area. Of all of these shapes would be finding the area of the flat surfaces. It's hard to break a sphere out to a flat surface. So for that one, we might want to memorize the formula. I don't know why I'm writing V again, where the surface area equals 4 times pi times r squared. And how I remember that formula is really, I just take away this divide by 3 in the volume formula for a sphere, and instead of being to the third power, because volume is 3 dimensions, surface area is only 2 dimensions. As I said, on an FSA or in class, you do get a reference sheet, but it's good to have a working knowledge of all of these so that you kind of understand where the formulas come from and how to find them. Certainly hope that this review has been helpful in going over what you're expected to know going into this chapter on different dimensions, how to find them, how they're calculated, etc.